Hi class, I'll continue with part 2 of a movie on normal distribution, finding a raw score. Suppose that scores on a particular test are normally distributed with a mean of 110 and a standard deviation of 20. What is the minimum score needed to be in the top 10% of the scores on the test? Carry your intermediate computations to at least 4 decimal places. Step 1 was to draw a picture of the normal distribution, labeling the mean and the standard deviation of 20, and also representing whatever they were asking us to find, top 10%, bottom 5%. So we have our normal distribution. Our mean is going to equal 110. We use the symbol mu for the population mean of 110, and the standard deviation is 20. The minimum score needed to be in the top 10%. If we're in the top 10%, that's going to be on the right-hand side. And so we want this area to the right to represent 10%. Maybe I'll make it look a little bigger. And we want to find this particular raw score, this particular x value for this normal distribution x, where the area to the right is 10%. Oops, I have 105. Let's fix that. So let's find the z-score that corresponds to the area to the right as 10%. So we're going to do z-box of 10%, and that's 0.10. And we use the Alex calculator, and that's going to give us the value of that z-score. Z-box of 0.10, and we have 1.281555, so we're rounding to 4 decimal places. So I go to the 5th place, 1, 2, 3, 4, 5. 5 is greater than or equal to 5, so therefore we know we're going to increase that previous digit by 1, so it's 1.2816. So now that we have our z-score, we're going to use our formula that converts a z-score to a raw score given the mean and the standard deviation. So the formula is given by x equal to mu plus z times sigma. So now I'll use my little annotation tool to make my Greek letter mu look mu-ish. Let's change that ink to blue. So that's mu, and that's sigma. When we substitute in those values, we get mu was 100, plus z, which was 1.2816, times our standard deviation of 20. So we'll substitute that value into the Alex calculator. So we have 100. By the way, I cleared that value out. Let me hit undo. I really could leave all those decimal places if I wanted to, but I'll go ahead and just change that to a 6, those last guys there to a 6. And then I can do 100 plus 1.28 times 20. And there I use the keyboard and use the Shift 8, which is the multiplication symbol, or if you have a keyboard on the right on your computer, you can use that as well. So I can put in those values and I get 125.632. It says round to the nearest, no, actually in this case it says round to 1 decimal place, so it would be 125.6. And then I always like to put that value in there and say, gosh, does that look like that's going to make sense that I'm going to get a 128.6, pardon me, 125.6? Is that going to work? If I substitute that in there and I look at it and I say, yeah, 125.6 is definitely to the right of 100, and that 10% is that area there. So and if you want to, you can actually literally find the z-score. If you took 125.6 minus 100 and then divide that value by 20, That's going to give you that z-score that's close to 1.2816. And sure enough, we get a z-score of 1.2800. All right, so let's go ahead and hit the check button, and let's do one where it isn't in the right, on the right-hand side, or isn't in the top 10%. Uh-oh. Oh, it's 110, not 100. Actually, you know what I'll do? I'll clear the drawing so it doesn't look so messy there. Clear all my drawings. And the only thing that we did wrong, if we hit undo, oh, I need to hit quite a few undos. There we go. Instead of 100, I should have had 110. So it was 110. All right, and we get 135.6. Hey, he says one of my digits is wrong. Now we see what it is. All right, so let's go ahead and check that. Zippy. So let's do another one where it isn't the top 10%. So this one says it's a failure if it's in the bottom 10%. Again, we have a mean of 11 million for these quarterly sales. So let's capture that, mean of 11 million. And then a standard deviation of 1.1, and it's normally distributed. And we want the bottom 10%. So now we want the bottom 10%. So that means that area to the left is 10%. And we have a mean of 11 and a standard deviation equal to 1.1. Let's use our annotation tool to fix our mean there. So that's our mean, and that is our standard deviation. All right, so let's first find the z-score that corresponds to 10% on that left-hand side. And if you remember from z-box says that the area to the right, that's how we find that corresponding z-score. But in this case, we have the area to the left. So how do I find the area to the right? In other words, I want to find this area here. I want to know the area to the right. Well, we know that the probability distribution represents the area underneath the curve. So we know that the sum of all the probabilities are going to equal to 1. So that means that all the area underneath the curve is 1. So if I know the left-hand side is 10%, which is 0.1, then the area on the right must be 90%, because 90% plus 10% is 100%, which gives me 1. So to find that area to the right, I just merely need to just subtract from 1. So I'm going to take 1 minus the area on the left. So 1 minus 0.10, and that's going to give me 0.9. So the area on the left is 0.9, or 90%. And therefore I can use z-box of 0.9, because once I know the area to the right, I can find that corresponding z-score. So if I select z-box of 0.9, it's going to give me a negative 1.28126, and that's a value that we just did earlier. And if you notice, on the left it's negative, and on the right it's positive. So the z-score would be a z equal to negative 1.2816. So that gives us our z-score on the left. So if you accidentally did z of 0.1, you would get positive, but because it's on the left-hand side, you know the z-score would be negative. However, when we get to the distributions that don't have negatives and positive, it's really important that you know how to find the area on the right-hand side, because all of these buttons on that second row are all z-box, chi-squared box, t-box, f-box. Those are all area to the right. So you always have to know the area to the right. So if you have the area to the left, just subtract that area from 1. Subtract that 0.1 from 1. All right, so now that we have our z-score, we can use our formula for finding the raw score. So our formula for finding the raw score is x equal to mu plus z times sigma. So this is mu, and this is sigma. All right, so let's go ahead and substitute those values in. So mu is 11. plus z, which is negative this time, minus 1.2816. So I want to use parentheses when I'm putting this in the ALEKS calculator, times 1.1. And it'll know to multiply the 1.1, so I really don't need the parentheses, but I'll just put it there anyway, just to be cleaner. So let's go ahead and use our ALEKS calculator to find that value. So we have 11 plus minus 1.2816 times 1.1. And we get 9.59024, and they say to round to one decimal place. So we go to the second decimal place, which is 9, which means we're going to increase the previous digit 5 by 1. So 9.6 million. And then we'll check our answer, and we've gotten it correct. So I hope this movie on normal distribution, finding a raw score, is helpful.